So consider this given problem statement. So it says that the sum of squares of all the real solutions of the given equation, that is log, and in the base we are having x plus 1, argument 2x square plus 5x plus 3, that is equal to 4 minus log base 2x plus 3, and in the argument we have x square plus 2x plus 1. The only thing is that we need to take care of the domain and the constraints with regard to this equation, right? So while solving and after getting the solution, we'll make sure that we check the domain and constraints properly, right? So first of all, I'll write this equation as it is, whatever is given, and then we'll try to manipulate this further. Now, here in this one, I'll factorize this equation. Whatever this quadratic expressions are there, I'll factorize this quadratic expression over here. So this can be written as 2x plus 3, 2x plus 3 times x plus 1. And this can be factored as, you can clearly observe, this is nothing but x plus 1 whole square. So this is x plus 1 whole square. Now, moving further, that is towards the next step. So here we can observe clearly one pattern here, that log of in this argument 2x plus 3 and base x plus 1. And if you observe here, this x plus 1 and this 2x plus 3, the argument and base locations are exchanged over here. So what I will do to simplify this, I'll use some smart substitution over here. So for t, I'll consider let t represent this log of base 2x plus 3 and the argument x plus 1. So from this we can clearly observe this thing and write that 1 by t will be log of base x plus 1, and in the argument this will be 2x plus 3. Now I'll utilize this property in order to resolve this given equation. Now moving further, so this one I'll use the property of log, that is product to sum. This is the product and I'll jump to sum. So this can be written as log of x plus 1 in the argument 2x plus 3 plus log of x plus 1 in the argument x plus 1, and this will be 4 minus log of base 2x plus 3. And instead of doing this, if you observe this power 2, this can be directly be written here, and this can be written as x plus 1 as it is. Now I'll make smart replacements over here. So you can observe clearly that log of base x plus 1 argument to x plus 3, this can be substituted by 1 by t. So 1 by t, and log of argument is same, base is same, and considering the logarithmic factor remains defined, so this will be 1. Now this will be 4 minus 2 times, and if you can observe, this is nothing but t. So this is 2 times t. Now on resolving this expression further, we get 2t square 2t square minus 3t plus 1, that is equal to 0. And on resolving this quadratic expression, we'll get t in the set. So one of the factor will be, one of the solution will be 1 by 2 and other will be 1. Now the journey is not completed yet, because we need to resolve this for t further, that is for x further, right? So now if I'll say that when my t is equal to half, so in that case I can say that x plus 1 is equal to 2x plus 3, and in the power we are having 1 by 2. So from this we can observe clearly that x square is equal to 2, and from this we can say that x will be equal to plus minus square root of 2. Now checking for this next value, that is when t is equal to 1. So in that case, x plus 1, this will be equal to 2x plus 3, and on resolving this we get x equal to minus 2. Now this has to be rejected. Now this has to be rejected because on the logarithmic equation, if I put this negative 2, so this will make my logarithmic factors undefined. Similarly, I need to reject minus root 2 because this will also make my logarithmic factor as undefined. So finally I can say the sum of squares of all the real solutions of this equation, this would be only holding true for this x is equal to square root of 2. So if I square this up, this would be square root of 2 whole square, and the answer for this one will be 2. So for this the answer is 2 and 2. Okay, and that's the entire solution and its answer. So I hope it is clear to everyone.